Let's quickly answer this question. In the figure above, Mn is a light uniform meter rule pivoted at O, the 80 cm mark. A load of mass 3.0 kg is suspended on the rule at L, the 10 cm mark. If the rule is kept in equilibrium by a string Rp fixed at P and attached to the rule at R, the 20 cm mark, what is the tension T in the string? So this is the diagram we've been presented. So they said this rule is in equilibrium and this is a string attached to it to also further keep it in equilibrium, and this is a mass attached to it as well. Then we are to find the tension T. Tension is a force. Find the tension T here. So the first thing we're going to do, we're going to, in equilibrium with respect to a beam or meter rule, we normally use principle of moment. Clockwise moment, if it is in equilibrium, then clockwise moment is equals to anti-clockwise moment. But when you talk about moment is what? Moment is force times perpendicular distance. So what am I saying? What I'm saying is that the force, the distance must be perpendicular. The distance must be perpendicular to the force. So if you look at this other force here, or this tension here that is also keeping this thing in equilibrium, it is suspended at an angle 30 degrees. So it's not perpendicular to point O, to this point of consideration, to the fulcrum. It's not a perpendicular distance. So that means we will have to resolve this T into its perpendicular component or into its vertical component. We will have to resolve it into its vertical component. So I'm going to redraw this diagram to now see, so that you can see what the new diagram will look like. So I've redrawn this. So now this string that is at this slant high, that is at 30 degrees, if you resolve it, at this slant height means that it has both the vertical component of that tension force and the horizontal component. And what brings about moment is a perpendicular distance. That's is the vertical component of the force or the vector. Is usually the vertical component that brings about moment. Moment is also defined as the turning effect of a force. So what I'm trying to say, if you keep this force, it is the vertical component of it, the one that is in perpendicular to the point of consideration, that will try to make this ruler to rotate or turn about this fixed point. Not the horizontal one, or the one that is not at 90, the one that is at angle 0. So if you are considering like the horizontal component of this force here, which will act this way. So assuming you are dragging this ruler this way, that ruler will not have a turning effect. It will not turn. But if you are dragging it upward, that's it, you at a perpendicular angle with respect to that point. To drag it upward, you'll be trying to turn this ruler this way. Or if you are dragging it downward, that means you will be trying to turn it this other way. So that is the understanding. So we are going to, so now you resolve this. Now someone will say, why is the vertical component T sine 30 degrees? Now you look at here is T. If you rule a parallel line or a vertical parallel line to this point, this point is the vertical, represent the vertical. So if you do sine, it's only sine that will relate t with this angle. Sine 30 will be opposite over hypotenuse. So if you name this place y, sine 30 so sine 30, sine is opposite over hypotenuse. So if you write sine 30, that will be what? Opposite, which is y, over hypotenuse, which is t, which is this t here. You know, if this parallel line is equivalent to if you draw the vertical component, which is represented here, parallel. So that's what it is. That's how we do this analysis. So if you make y here the subject of your formula, you now have that y will be equals to what? T sine 30. That means this vertical axis is equivalent to what? T sine 30. So that's how we resolve this tension on the string on its vertical axis, because it's the vertical axis that will make it have a turning effect, because it is at 90 degrees angle with respect to the fulcrum. Okay, and enough talk. So let's continue with our calculation. So now it's time to take moment about the fulcrum here. Now this mass here, 3 kg, is acting anti-clockwise. That's this way. It will tend to turn this rule downward this way, with respect to this fulcrum here. It will tend to turn it downward. Then this vertical component going upward will be clockwise, because it will tend to try to turn the rule this other way. So in the end, both of them will end up keeping the rule in equilibrium. So we'll take our moment. So we take moment for this first 3 kg mass. So the moment there will be the mass there. You can convert it to force or to weight by multiplying it by acceleration due to gravity, which is approximately 10 meters per second squared. But let's just leave it at the kg for now. So that will be 3 kg times the distance from that point to the point of consideration, which is the fulcrum. So the point of the fulcrum is 80 cm or meter, whatever it is. It wouldn't really matter because they will cancel out. It's 80 and here is 10. So distance from here, L, distance from point L to O will be 80 minus 10. 80 minus 10 will give you that distance, equals to, there's no other force that is acting anti-clockwise on this side or any other side. So we go to the opposite side, which is the clockwise, which is T sine 30 times that perpendicular distance. So this point of R is 20 meters or cm, whatever it is, and here is 80. So distance from R to O will be what? 80 minus 20. So this will be 3 times 70 equals to sine 30 is 1 over 2. So that would be the same thing as saying T times 1 over 2 times 80 minus 20 is 60. So 2 will cancel 60 30 times. 2 cancel 60 30 times. So 3 times that is 210 or 210 equals to 30 times T, 30 T. So if you divide both sides by 30 to make T the subject of the formula, so you have that your T will then be what? 210 divided by 30. 0 will cancel 0, 3 will cancel 21 7 times. So your T will be 7 kg, not Newton. It will be 7 kg. The reason it's 7 kg is because the other mass here, the other force here is in mass form, is not converted to weight or force. So it cannot be. So your final answer here will be 7 kg. Then for you to properly convert it to a force, because the tension you are actually talking about a force, you multiply it by acceleration due to gravity, which is approximately 10. So that will be 7 times 10 to give you what? 70 Newton. So the tension T on that string is 70 Newton. Do we have it in our option? No. The option we have here is 7.0 Newton, in which I disagree. It should be 7 kg. That's if it is mass. So it's not 7, it's 70 Newton. I would like to see your opinion in the comment section about this, but this is what it is. Alright? Thank you very much. Subscribe, and also for online tutorial, you can join my WhatsApp group through the link in the description, and then we schedule. Thank you.